Security used to be simple. I mean, you had a desktop computer, right? And it connected to a phone line and later to the internet. You got a firewall, you got anti-malware, and you were golden. You were doing security, right? Then we started to get mobile devices that did more than just phone calls. Then lots and lots of other mobile devices that otherwise depended on the internet. That's when things got really, really weird. For example, we've already seen how zombie devices out in the field could be used to launch denial-of-service attacks in a botnet. Or the thousands of Tesla car owners that got locked out because their keyless entry system didn't connect to an API server. Or the Cruise driverless automated vehicles stopping on the streets of San Francisco because of a communications failure. Having code, having communications on millions, if not billions of devices worldwide, well, it's becoming a bigger problem. For example, as we'll hear at the end of this podcast, you might not want to throw out that smart home connected light bulb, at least not without first resetting it to the factory default settings. Yeah, things have gotten weird. This then is the story of a device security framework, one that could possibly harness updates and provide all of us with more security in the devices we find in our lives. I'm Robert Famosi. This is Error Code.
I'm Window Snyder, the CEO and founder of Thistle Technologies.
Perhaps you've heard of Window. She was director of security architecture at Stake. She then worked at Microsoft in their security engineering and communications group, where she created the Blue Hat Microsoft Hacker Conference. She then worked for Mozilla, makers of Firefox, and Apple. She then became chief security officer for Fastly, then worked at Intel before moving over to Square. In 2021, she created her own company, Thistle Technologies, to handle smart devices.
We're building security tools, libraries, and backend services to allow device manufacturers to quickly get to a modern security architecture.
Prior to the show, Window and I discussed the scope of our conversation and agreed we were going to be discussing devices in general, so as to be inclusive of commercial and industrial or enterprise, and to include IoT and OT.
A lot of devices have stripped down versions of operating systems or very minimal operating systems. Sometimes you don't see a lot of separation of privilege or even separation between code and data, which leads to the kinds of problems that we saw in general purpose operating systems decades ago. So at a time where you would see, let's say, you could execute code right off the stack. You could execute, you could compromise a computer with a single vulnerability that was accessible from the network, and then have complete access to everything that the system has access to with very little in the way of mitigation. And operating systems, as you know, well, general purpose operating systems have layer upon layer upon layer of security mitigation in place to make it more and more difficult for any one vulnerability to compromise the entire system. But devices have a lot less of that in place. And I wouldn't say that's universally the case. There are folks who've made significant efforts to do this work, but it's definitely applied inconsistently. We definitely have this kind of mixed environment where you've got some devices with a fairly robust security architecture and some devices with hardly any work at all. And then you've got devices that are actually within the device themselves mixed together.
Windows touched upon an interesting point. A mobile phone has its own operating system, but then it's also got individual dedicated chips, like a radio chip, components that are contributing to and making your mobile device more complex.
Let's take a phone with a very robust operating system, but then also has a radio chip, maybe your Wi-Fi or your Bluetooth, or that would have firmware on it that doesn't have this kind of capability. And so the opportunity for the attacker is always going to be that there are these low-level components that have access to the device that don't have the same kind of protections that you see at the operating system level, which of course makes sense. These are very resource limited processors, and there's a limit to what you can do, but there's more that we can do. So we we really need to start paying attention to that. And it's a growing problem because these devices grow in complexity, and then every device, every object, it seems at this point, has processors and memory and radios, and they're connected to networks, and the problem space is growing, but the security investment isn't, not at the same scale that it needs to be.
In some ways, I consider the phone to be kind of a success story. That unlike a laptop, you don't need a firewall and you don't need antivirus running. You don't need to have the tools that you would have seen on a network server long ago. Mobile phones don't necessarily have to have those because, well, the attack surface, for whatever reason, has changed. Our mobile phones, for whatever reason, tend to be more resilient. And I'm wondering if we could see that type of evolution happening with the devices that we're talking about today.
I think it's possible, but I think the phones are kind of a special story because, first of all, I would say that degree of security resilience was not evenly applied across the mobile phone story. And one of the things that was, let's say, most interesting and true about how viruses and malware get on your system for laptops was that overwhelmingly users were installing it themselves. So, I don't know if you remember those, your PC is already compromised. Download this thing and we'll scan your PC today. Like people were downloading and installing, all kinds of stuff from everywhere. And you know what, honestly, they should be able to do that without fear. But like this was the case that they were, downloading, installing stuff that would have viruses on it or malware or lead to compromise in one way or another, or just here's some functional software that legitimately comes from the vendor that you think it does, and also it's just hugely vulnerable, and eventually the attacker is going to leverage this and use it to compromise your device.
And this complexity is starting to spill out into our lives as manufacturers decide to put Zigbee or Bluetooth Low Energy or MQTT into any device now and call it smart. Here's where the devices are being retrofitted with extra chips and things not architected with security in mind.
Yeah, I mean, I'm not even sure you can buy a dumb TV anymore. You just use it as a display for some other device that's more robust, but like they all want to attach to the network. They all have a lot of value-added features that require network access, and there's not the same degree of investment to protect all that capability and all that attack surface.
This is a good point. Just because you've got a protocol or a chip that can handle a certain type of communications doesn't mean it fits the security architecture of the new device that you are putting it into.
You take a technology, protocol, or an implementation that was designed to be used under a certain set of security expectations or even performance or reliability expectations, and you apply it to a new environment, a new technology, a new environment, and the security expectations or requirements don't come along for the ride. And so if you don't do work to evaluate whether or not the implementation is sufficient for your security requirements, then you're very often going to find yourself disappointed later when someone else exposes it to you.
Part of this, I think, comes from the continued reuse of older protocols, some that weren't really meant or designed for their current use. Yeah, I'm looking at you, MQTT.
It's definitely widely in use, but honestly, this happens. I mean, like, I've been in security for a long time, and so have you, right? That this is a problem that we see happen over and over again in lots of different ways. That you take a protocol or a implementation that's designed to be used. One of my favorites actually is SCSI, like the SCSI, like between the interface between like used to be your hard drive, right? And then someone decided to take that and make it iSCSI, and that's deployed over networks for network accessible drives. Like, what a fantastic idea! Except the kind of resilience that you'd expect to see in a protocol that's designed for network use was not in place. So like that was a really old example, but like honestly, it keeps happening.
And early Nokia phones, they had a lot of viruses and malware. And I'm not saying that doesn't happen today. It's just much less of a story than I expected it to be. The way we saw PCs evolve and the explosion of viruses and malware in the early 2000s.
Is different here is that some devices, let's take iOS, for example, if the software on your device comes from a known location, right, like the App Store, then there's an opportunity there to create an environment where there might be a degree of inspection that goes into those. Or even if there's no inspection, there might be an opportunity for, when it's identified, it could be removed and no longer available to other devices. It's really a different model, right, on iOS in terms of how viruses and malware got on PCs. So we're not really comparing apples to apples. And on OS 10 or Mac OS, people were downloading software from everywhere. But today, mostly the best place to get software for your Mac is from the App Store. But even if you download it from other places, if it's not signed with a developer ID certificate and the operating system doesn't recognize it and it doesn't execute, and you actually have to go through pretty serious contortions before it will execute on your system, that is not like a click through, because of course the person's trying to get something done. They want to get it to execute on their device. So of course, a click through would enable that software to be almost as successful as, throwing up a warning is insufficient, right? So those strategies have changed over time on some platforms. So that's why you've seen, let's say, maybe a different story on mobile phones. It's not the only reason. That's a pretty significant part of it. That if the largest factor was people were installing malware themselves, then here's a pretty significant road bump to allowing those systems to be compromised.
And we're already seeing some examples of exploitations in devices today. I'm thinking specifically of the Mirai botnet, which was comprised of surveillance devices that had a white label chip inside that was used over and over in a variety of different brands, so that it got enlisted into a botnet composed of thousands of these devices worldwide.
Yeah, I mean, it's really common now. Device manufacturers are taking off the shelf components and then recompiling them into something new. And sometimes those new devices have security requirements that those device components were not designed for. So like, for example, you might take a gyroscope off the shelf, and some of these new satellite startup companies might incorporate a gyroscope off the shelf that wasn't necessarily designed to be deployed in a satellite, and now have the same security requirements that a satellite might have. So those components, or those technology modules, or whatever we're talking about, they need to be evaluated for the new security context, because they are not necessarily built with those in mind. And sometimes they are, but very often they're not. And if you're moving from, let's say, something that's a general purpose implementation to something that has high security requirements, you absolutely need to do that work for all the different components you incorporate, whether that's like a technology, like a hardware component, or whether it's a library that you're incorporating from, maybe it's widely in use and it's popular, and, a compression library, for example, right? But you need to consider what it means for the security context for the device that you're building.
So we're talking about systems on a chip. They're limited in resources in some cases, and they max out the resources just running the firmware or the code that they're supposed to run. So how could they possibly be updated? And in some cases, how can they even be secured?
Well, going back, for devices that are highly constrained, that were built to for which the software is at the limits of what the hardware can do, like that's a very difficult problem. But we are constantly building new stuff, right? And as we build new stuff, we need to, let's say, decide that a reliable update mechanism is a requirement. And if that's the case, then maybe what is required for this device to deliver on the reliability requirement is that it requires failover for updates, so that a problem with an update doesn't mean that device is completely bricked, right? Like for a phone, that might mean it has to come back to the mobile store. And for a TV, it might require a technician to actually visit the house. And for a car, it has to come back to the dealership. And for a satellite, it's just gone forever, right? So the requirements for these devices to be able to be reliably updated are kind of on a different scale than you would otherwise think about for example, updating a web browser. So you might decide that for a device that we're building today, that you actually do need storage that is sufficient to allow maybe dual partition, so that you always are able to have a bootable partition that allows your device to execute, so that you can, that would be like the most reliable to do update. We have actually got an update mechanism that allows you to do that. But there are other, let's say, gradients between that and just like YOLO, throw out the update if it fails, and goodbye device. But you need to figure out which update strategy is sufficiently reliable for your requirements. Because what we've got today is devices that maybe have an update mechanism for which the device developer doesn't have enough confidence in it to actually ship updates. So even for devices for which there's, let's say, a known vulnerability and it's potentially critical, and even potentially actively being exploited, the cost of delivering the update to those devices with, let's say, a 1%, a 2%, a 5% failure rate might be that they decide not to ship the update broadly because they can't tolerate the cost of dealing with a failure rate that is that high. So you need an update mechanism that is reliable enough to allow you to actually ship updates with confidence. And actually, when you get to the place where you can ship updates with confidence, you're not just shipping security updates. You're also enabling the opportunity to ship updates for functionality and for potentially even introducing new revenue streams by allowing the device developer to ship updates with new functionality that's paid because you're able to have confidence that it will deploy. And kind of everyone wants to get to that space where Tesla is, where they can ship you a software update and you've got new features in your car. Fantastic, right? Most hardware manufacturers would love to be able to have a relationship with their customer that goes beyond the point where the product leaves the store, leaves the device manufacturer.
In addition to the surveillance cameras being hijacked to form a botnet, there have been other cases where updates to devices over the air or otherwise have proven to be disastrous.
Well, there have been events where smart locks got bricked with an update and people got locked out of their Airbnbs. I remember a very long time ago an update failure that required bank ATMs to be updated manually, like all over the place. Like thousands of ATMs need to be updated manually by a technician that had to go visit them. We've seen cable modems that have vulnerabilities that nobody wants to update because the possibility of having all these failures resulting in consumers without network access calling the provider to try and figure out how to get back to a working state is intolerable. And so we see those home routers and cable modems, never updated. And so those vulnerabilities persist.
So given this new threat landscape, Windows created a new company, one that is looking at a device-agnostic framework as a solution.
You can actually apply it to older devices as well. It depends on the hardware constraints. Some devices have an update mechanism that could be leveraged in order to update the low-level components, but that's really specific to your implementation. We want to support folks where they are, right? We want to work with device developers, leveraging the tech stack that they're using today, instead of requiring them to do a forklift upgrade to move to a whole new operating system, right? So the idea is that we've got these different technology components that can be incorporated into your device, and among those we've got an update mechanism that is reliable, allows for failover, that the updates are signed and validated, and just what you'd hope to see from a more secure update mechanism. Got a memory allocator with memory corruption mitigations, more memory corruption mitigations than a lot of the default memory allocators to make it more difficult to exploit memory corruption issues. We've got a TLS stack that's implemented in a memory safe language because it would be ideal to get to the point where you could say for your device that all of your network facing attack surface is implemented in a memory safe language, and that could dramatically reduce the opportunity for memory corruption issues to potentially result in vulnerabilities or exploitable vulnerabilities for your product. So what we were hoping to build is a platform that allows developers to incorporate the security functionality or security sensitive functionality that they need in order to get to a robust implementation without having to throw away their existing technology investment.
So around 2007, I was sitting at Black Hat in the embedded security talk track and thinking how we're just talking to ourselves. We need to spread the word about device security to the greater world. And so I wrote When Gadgets Betray Us. Released in 2011, it was early. In fact, the term Internet of Things was just being touted at that time. So I wonder, what's changed? We've known this for the last decade. What's different today?
So there's definitely growing pressure both from security researchers, from active attacks, from regulatory bodies as well. And I think the enterprise has a lot of, let's say, power here as well in space to move their device manufacturers to a more reasonable security posture. Like when a security officer or a security buyer, or even a buyer that's halfway security savvy says, what is your update policy? How long is this device going to be supported with security updates? Which components are you incorporating into this product? Like making an SBOM available is required for selling into to government agencies, but it's also now just security savvy enterprises are asking for this. So it's going to become a requirement for some enterprises, because the security questionnaire with 200 questions on it is, exhausting for both the vendor, but also for the security organization to say, like, is this sufficient to our needs, and how do I balance the other factors that we need to consider while figuring out which of these security limitations we can tolerate with this vendor. We want to make it easy for folks to reduce that security friction in sales, right? That they can say something really comprehensive about their security implementation that is meaningful, right? Instead of like, well, we've got really smart people, working hard to make this secure, which is really difficult to measure compared to all of our network-facing attack surfaces implemented in a memory-safe language. That means something specific, right? It's measurable. Our update failure rate is this, and so that allows us to enable the enterprise to deploy security updates on a schedule that's appropriate for your organization. Those are things that I cared about as a CISO, things that I cared about as a buyer, and that would make a difference for me when I'm trying to evaluate these incredibly complex environments. That, like, the devices in the enterprise are no longer like just the printer. Now it's like every room has many devices. Like every part of the organization is dealing with multiple devices. Like even a conference room has like probably a free busy scheduler on the wall, and then it's got like a smart mic on the table, and it's got a screen, which is a smart TV, and it's got a whatever they're using for conferencing, maybe even an Apple TV or something attached to that, and the camera might even have be Wi-Fi enabled. It's just that's just for a conference room. Never mind like the HVAC or the physical access or any of the growing number of devices that the security organization needs to think about in terms of the complexity. And for an IT department, these are essentially black boxes, right? You may or may not have the capability to investigate this in your own organization, but like you shouldn't have to. It's a huge investment to try and do that security work to evaluate whether or not this is sufficient to your security tolerances. Like this is something that the device manufacturer should be able to spell out and with confidence be able to describe what they're doing in their devices for security.
I remember a few years ago talking to a company, and they patiently explained to me that the solution could only work with a certain number of chipsets, not all of them. Window, she has a framework, and it works with just about anything that's found in a device today.
So we support a number of hardware platforms and operating systems today, but we are growing that over time. And importantly, we want to work with our customers. If we've got a customer who wants this functionality and their platform's not supported yet, we will support your platform. We want to make this accessible for our customers. So yeah, growing our ability to support more and more platforms is a part of the challenge, but it's critical because this capability is required for pretty much every device out there.
And what Thistle's doing, it's pretty clever, actually. Developers add some line of code before the build, and then they compile it. They put it out into the field, and then remotely, they can look at a dashboard and monitor the health of that device, and they can even push out updates if needed.
Yeah, that's essentially the story. For update, it can also help you. Our developer tools allow you to partition the device. So you've got the failover partition. You've got the components that get compiled and deployed in the device, and we've got the backend services that allow you to manage your devices or enable your enterprise customers to manage their devices.
So in some cases, this will actually introduce some basic security features.
Yeah, those updates are signed and validated, of course. We want to make sure that the update for your device is coming from where you expect it to be and from nowhere else.
So there's a difference between the commercial devices out there that are becoming smart and the operational devices that are out there in the world running our elevators and escalators. Would this solution framework work on PLCs and SCADA environments?
Yeah, I mean, it depends. Like for all these devices, they can. Yeah, we can make it work with a lot of different kinds of environments. I think one of the places to really assist those folks is by working with the systems integrators, right? Who are building a lot of devices for these whether it's industrial manufacturing or it's power and water or telecom, that they build it for that specific organization or that specific, let's say, municipal water department, and creating the tools that allow them to provide a solution that incorporates more robust security is a great way to deliver that capability.
And I hear a lot from people that have been in the business for 2 to 3 decades, and they say they're seeing the same thing over and over. Any guesses as to why we're reinventing the wheel?
Honestly, sometimes I think I'm doing the same job everywhere I go. And for the last, it's closing in on 30 years at this point. Not actually 30 years. It was like almost 28 or I don't know what. So it's a very long time at any rate. Um, and yeah, I see the same security work that was reliable and made sense and made the biggest difference in the mid 90s is still the same work that makes sense and works in a meaningful way today. So things like highly reliable compartmentalization, separation of privilege, separation between components, and reducing communications channel down to minimum access, so that you're able to mitigate the reach of an attacker from one component reaching the next component, whether that's systems on a network or it's services within a backend operation. Those kinds of strategies are still most effective. Then things like making sure that you can update, address any kind of security issues, because you will identify security issues. You're not going to ship something fully formed and perfect into the world. You're going to identify new things that you want to address over time, and being able to do it reliably is a critical aspect. Things like reducing functionality, there was a time where Microsoft would build, let's say, Office. Office is a fantastic example, with every feature that anyone could ever want ever, and the set of people who were using any one feature was really small. Except maybe there's a base set of features. Let's say it's 20%, and most people are using that set of functionality. And then the 80% of the implementation was leveraged by really small numbers of people. 2% of the population is using this feature, and 1% of the population is using that feature. So they kind of felt like you couldn't get rid of anything because the people are using it. But it also meant that everybody had the attack surface from all that functionality, right? I don't want to pick on Microsoft or Office for this case, because it's actually true in lots of places. So the strategy of identifying the core functionality and making that available to everybody, and then reducing the exposure from all that other functionality that is only used by small populations of your customers. You can do that in a lot of different ways. For example, you can make it an additional module that you can load, so that the default product doesn't ship with all that capability accessible. Or you could make it only enabled through a configuration option, which means that because most of the population for these products, they use the product the way it ships with the default options, and fewer people go in and actually change those options. So if it's a configurable option, then that's going to dramatically reduce the attacks, or the number of people who or users who are going to be vulnerable to a problem in that component. So those kinds of strategies are still what works today. That adding more and more capability adds more and more complexity, adds more and more attack surface, and more opportunity for attackers. And it's also harder to manage from a security perspective. It's harder to do security work consistently across hugely complex code bases or hugely complex networks. And so if you accept that complexity is unmanageable, then simplicity ends up being your security partner, that you want to identify ways to reduce the opportunity for some minimally used component or service or server or system to be the reason that the entire body is compromised.
Windows background resulted in us having better security today. I wonder, what sort of common things is she still seeing? What carries over from the InfoSec that we had 20 years ago to the InfoSec that we're seeing today?
I think there are opportunities for education for when we're teaching people how to code, teaching how to code with security considerations in mind. But I do see progress as well. So a lot of the memory corruption issues that we used to have to deal with are now reduced to a smaller set of the new code coming out, because not everyone's writing with these low-level languages like C and C++. More and more people are using memory-safe languages, which is fantastic. There are more applications being written in Go or Swift or Ruby or Rust, my current favorite, right? So being able to move to memory-safe languages has dramatically reduced the opportunity for memory corruption issues be present in new code. Not everyone can use these memory safe languages for what they're building, but the fact that they're gaining in popularity and that we have more and more of them is massive. So I'd say we do have areas where we're making huge strides.
That's not to say our work in security is done.
I do think that there's a huge amount of work here to do, but I also think that it shouldn't be as hard for device developers to catch up the way it has been for general purpose operating systems, because we can leverage some of the, like one of my favorite examples is to talk about cryptography. And once upon a time, cryptographic libraries were implemented by like every development environment. And we've come to, as an industry, mostly agree that what you should do is leverage a handful of existing cryptographic implementations, that you should not roll your own. Don't go it alone. You should leverage one of these well-tested, robust implementations that were implemented by people who understand cryptography and, more importantly, understand how cryptographic implementations can fail. And use that and build the functionality that's specific to your product. Above that, leveraging this robust implementation. And the same is actually true for security functionality. This is the model that we're using at Thistle Technologies. We want people to leverage, let's say, an update mechanism that is reliable and robust and does validation properly. We want folks to be able to incorporate this kind of security functionality quickly and easily without having to build it themselves, because not everybody has a security engineering organization that is equipped to build this kind of functionality to the degree of resilience that your products are up against. And then additionally, even for organizations that have that security engineering organization that is equipped to build code to this degree of resilience, they have a laundry list a mile long of things that they need to go do. So being able to support them by doing the security plumbing and allowing them to focus on the security components that are specific to their project, their implementation, that really frees up their time and allows them to scale their investment. So for having built those security teams, I know those folks are in high demand and short supply, and there is an infinite amount of things that they need to go address. So we're hoping to support those organizations as well by reducing the work that they need to go do, and also allowing them to deploy that consistency, that security consistency across their products really quickly, and allow them to focus their attention on the security work that is more specific to their product.
So with commercial devices, there must be a price point where the manufacturer or vendor simply decides it's not worth updating.
For some devices, yeah. If we're talking about like a smart outlet, like maybe you're just like, well, that was $19, I'll go get another one, maybe, right? Although I feel like that leads to, obsolescence before when would your outlet stop working otherwise, right? Like that there's no update for it. That might be like a reason for you to get it off your network, but it probably still functions as an outlet, right? So the ability to apply security updates is a pretty significant part of it. That's fine for your outlet. But if it's an MRI, you're probably not going to toss it just because it's got security vulnerabilities and the manufacturer didn't supply you with an update. And it's true for cars. Like the car that I buy today and drive around for 10 years and then sell to somebody else who drives it around for 10 and sells it to somebody else who drives it around for 10, that car should still be as functional, with maintenance, as it is today. So we have to plan for devices to be functional, given the capability of the major systems on the device, beyond, let's say, our ability to have confidence in the security of that device. We're not going to throw away, we shouldn't even throw away that smart outlet, right? But we're not able to throw away all these other devices. So we're really relying on device manufacturers, device developers to catch up with the security threats that are out there today.
So what about something like a smart light bulb? It seems like it's kind of questionable gray area because we're used to changing our light bulbs and it's not really a big deal. But on the other hand, if it's hooked up to your home network, if it poses a security issue, then maybe there should be a way to update it. Maybe there should be a proper way to dispose of it.
Oh my gosh, these are not like the set of things that we need to consider now are growing and growing. But like that smart LED light bulb, you probably paid $20 for it too. It's like you might be in the habit of, or you might remember the days when you would throw away an incandescent light bulb when it stopped working. But that was a 69-cent light bulb, and this is like a $20 LED smart bulb that should continue to work for thousands, tens of thousands of hours.
So this is a very good question. I mean, if you've got these disposable internet-connected devices, then really we're handing our credentials over, aren't we?
If you're able to reset it to factory settings and completely throw away the data that was stored on it, then that should feel more comfortable if it's a pretty big if it was implemented properly, right? That reset might still leave traces of credentials and things, like your Wi-Fi password on the device that can be leveraged by somebody who gets their hands on it. So yeah, we absolutely need to think about this for all the devices that come in and out of our corporate networks, in and out of our homes even.
In addition to sorting our garbage by trash, recyclable, or compost, we got to remember to reset the device and get it back to a zero state.
Reset it and also hope that their reset is actually, is it a reset? Like I'll reload a new configuration, or is it a wipe where I'll get rid of any data that was present on the device? I hope a wipe, but I fear it's a reset.
I'd really like to thank Wenda Snyder for talking to me about her new company, Thistle Technologies. Really, it's the wild, wild west with connected devices present in our homes, in our place of work, and in the world at large in terms of security. We've discussed this before, and unfortunately, we'll probably have to discuss it again. But it is my hope that at least we're starting to make some progress in the security of all of our devices. Hey, if you're enjoying Error Code, tell a friend. I'm sure there are other people out there who like narrative information security podcasts. And I'd really like to hear from you. DM me at robertvamosi@infosec.exchange on Mastodon and tell me what you like and even what you don't. And coming up, I've got some great episodes talking about infrastructure and the cybersecurity strategy that the Biden administration just released, and also a deep dive into what we mean by the electrical grid and how secure is it really. I hope you'll subscribe so you don't miss out.